Okay, so this is 16.1, and it is about circumference and area. So on 853, here we go, it says applying circumference, and circumference is equal to 2 pi r, or circumference can be equal to pi times diameter. And that makes sense because 2 times radius equals diameter, right? So B says says find the circumference, and it gives us diameter. So I'm going to say circumference equals pi times diameter, and so pi times 2. And see, it's telling us to use 3.14 for pi. And so you just stick that in your calculator and you've got it. Now this shows it using radius. And you can do that 2 times pi and do half of the diameter, which would be 1. And then put that in your calculator. So number 4 says the circumference of the tree is 20 feet. What's its diameter? Well, I'm going to put 20 in for circumference, and then I'm going to solve for d. So I divide both sides by pi, or this says 3.14, and I end up getting 6.37 for the diameter. 5, try by yourself and then come back and look and see if you did it right. Okay, you should have set it up just the same way we set up number 4 and get 10.19 feet for the diameter. The next page we're going to look at is 855. And it's applying area. Now area is equal to pi r squared. And that's easy to remember. The area gets the squared because that's what all our answers in area look like, isn't it? So B says a slice of circular pizza is 9 inches in length. What's the entire area of the pizza? So area equals pi r squared, and it says a slice of pizza measures 9 inches in length. Okay, so that's going to be the radius, and I will do pi times 9 squared, which gives me about 254.3. Try your turn and then come back and see if you did it right. So it gave us diameter, and so we have to think, well, radius is half of the diameter, and so we use it, and it's exactly ended up the same answers we got in the one above it. And that is it for 16.1. So then we're also going to look at 16.2, which is arc length and radian measure. And so if we, and the essential question here is how do you find the length of an arc? And so if you look here at what one is, an arc is an unbroken part of the circle consisting of 2 points called endpoints and all the points in the circle between them, which we know because we've been working with it, right? And arc length is understood to be the distance along a circular arc measured in linear units. Okay, so arc length, we've been looking at the degree of an arc, and now we're going to look at its length, okay, which is done in like feet, or it says centimeters, okay? So if we look on the next page, 864, we see the formula. The arc length, S, of an arc with measure m degrees, and a radius of r is given by this formula. Okay, so the length equals the degree measure over 360 times 2 pi r, okay, times the circumference formula. And see, what's happening is, let's say this is 60, let's just say this is 60 degrees, okay? So 60 over 360 is 1/6 of the circumference. Do you see how this formula is actually relating to the circumference formula? Circumference is all the way around, measuring the distance outside the circle. And when we only want a specific piece of it, like in this case, 1/6 of the circumference. And that's where that formula is coming from. So flip the page, and we'll do this problem. The minute hand of a clock is 8 inches long. To the nearest length of an inch, how far does the tip of the minute hand travel as time progresses from 12 to 12:45? Well, if you think about that 8 inches, that's going to be the radius, isn't it? And then we want from noon to 12:45. Okay, that's 45 minutes out of 60. So, isn't it? And you also know that that's 3/4. So 45, and I'll show you how. 45 out of 60 minutes, if you simplify that, you get 3/4. So we want 3/4 of the circle. So 3/4 times 360 is 270 degrees is the measure of this arc. So from here to here is 270 degrees. So my arc length equals 270 over 360 times 2 pi r, which is 8. And when you put that in your calculator, we can find out that it's 37.7 inches. On the next page, they're talking about converting radian measure, and at first, they're right here, you can see constant of proportionality. Okay, and what they mean is this part of the formula is a fixed proportion, okay? And this ends up being what they call the radian measure, okay? So we are going to convert angle degrees to radian measures. That's the next thing that we need to learn. So if you look at, well, let's do, if you just look at A, to go from degrees to radians, okay, you're putting the degree over 360, and then you're multiplying it by 2 pi. And so when we do 60, we're going to say 60 degrees equals 60 over 360 times 2 pi. And then you would get 1/3 times pi, because that would end up to be 120 over 360, and we write that as pi over 3 radians. Now if you turn the page, we'll do one more example. Convert each measure to radian measure. So 90 degrees is going to equal 90 over 360 times 2 pi. And that becomes 180 over 360, which is 1/2 times pi, or pi over 2 radians. You try the next one and then come back and see if you check your answer and see if you did it right. Okay, so you should have gotten pi over 4 radians. Now I'm going to recap real quick. You have circumference, which is 2 pi r, or pi times diameter. You have area, which is pi r squared. You have arc length, okay, which is m over 360 times 2 pi r. And you have radian, which is equal to m over 360 times 2 pi. Okay? And so those are what you need basically to do this, the homework.